Welcome back to the fourth and final module of the course. This is Anthony Roblick. We have another tight schedule today, so to better respond to as many questions as possible, as with the previous modules, please type them into the chat and the staff will do their best to get to them. Alternatively, feel free to email those questions to us at our DWQ address. Also, just as a reminder, also as with the previous three modules, we are recording this session. So we please ask that you keep your microphones muted during the presentation, and we really appreciate your cooperation with that. So with that, let's go ahead and get started. So here's the agenda for Module 4. As you can see, most of today will be dedicated to providing example reviews, which will tie together all the material that we had covered in the previous three modules. So there are a total of 3 review examples, followed by some of the most common issues we've seen from our audits, and that's followed by quiz 4 and its review. And after we review for the quiz, we'll end the day with an update to our MS4 program, along with some closing comments. So let's get started with example 1. This is an example of a plan review. You don't have to follow this exact way, but this will be a plan review that covers everything from start to finish. You'll see some examples later where that isn't the case. Just to note, this project, or the project in this example, and the projects in some of the following examples presented today, were reviewed prior to the rule amendments effective March 2nd, 2020. But much of the process of reviewing the site, as shown in these examples, is still relevant. So the goals of this presentation are the same as the goals of any stormwater review. We're going to review the site plans and stormwater management report, and we're going to identify any errors with the design. So first question to ask is this project a major development? So does it trigger municipality's stormwater control ordinance, or in this case, the residential site improvement standards? Does it disturb more than an acre? And in the past, when the site we're about to see was reviewed, the question was, does the development increase impervious coverage by a quarter acre or more? However, under the current stormwater management rule, the question is, does the development increase regulated impervious surface or regulated motor vehicle surface by a quarter acre or more? Even if the quarter acre major development trigger isn't in your municipality's ordinance, remember that the quarter acre increase in motor vehicle surface is also the trigger for when water quality treatment is required. So this municipality did adopt a slightly different definition of major development than what's in the MS4 permit. They include the 1 acre disturbance, but they also include anything that creates more than 10,000 square feet of new impervious surface, which is just about a quarter acre. But both are the trigger for major development in this municipality. So the next step would be to familiarize ourselves with the site, so we can determine if it's a major development, and if so, which requirements would apply. So we would look at what the existing land cover is, and what can be a trickier question on some sites, although it won't matter on this site, is has that land cover existed for the past 5 years? Because if you look into the stormwater management rule or the SCO, it will require use of the land cover with the lowest runoff potential that has existed in the last 5 years, if the area had more than one land cover in that 5-year period. In this case, we don't have that situation, but you can run into that situation where a site has been developed recently. So this is the pre-developed site in this case. We can see that it's mostly wooded. There are 2 cleared spots at the center of the site, you can see, that appear to have maybe a roadway or a right-of-way for utility heading through it. And this is what the engineer submitted with the stormwater management report. So for the existing coverage, there's 19.71 acres of woods and 0.95 acres of open space. For this project, we could assume that this is correct. You could go out and check this. If you look at the site in GIS, you could measure those areas even, but this information seems correct compared to the site plan and doesn't really signal out any as requiring any further checking. For the proposed conditions, there's going to be 5.5 acres of road, roof, and driveway, 8.25 acres of open space, and 6.91 acres of woods. So they're disturbing a pretty good portion of the site, but they aren't getting rid of all the woods. So here's the site plan. It's a residential development. They're constructing homes, roadway, and 2 buildings in the center of the property. Also in the center is their stormwater management basin, which is an infiltration type basin, and that's the feature here shown in yellow. So based on the plans, there are 13.5 acres of disturbance. Therefore, by any definition, this is a major development. There's an increase of impervious area by 5.5 acres. So the conclusion is that it's definitely a major development because it exceeds the 1 acre and also creates more than 10,000 square feet of impervious surface. So let's talk about which standards are required in this case. Water quantity is definitely required since it's required for all major developments. The only potential exception for water quantity would be if it's being discharged into a tidal flood hazard area. And this site is not in a tidal flood hazard area at all, so there wouldn't even be an evaluation as to whether or not this development would qualify for that exemption. Water quality, we saw there is a 5.5 acre increase in impervious surface, so that's over the 1/4 acre that's required for water quality. This project was reviewed again under the old rules, the rules effective before March 2nd, 2021. So the water quality is based on an increase in impervious surface. However, even under the current rule, it definitely has an increase of motor vehicle surface greater than a 1/4 acre, so would still require water quality treatment. Groundwater recharge, this is in planning area 1, but since it isn't previously developed, it does not qualify for the exemption. We saw in the existing condition site plan that the site is roughly 95% woods, so it's not previously developed and it's not exempt from groundwater recharge. Also, under the new rule, this site would have to meet these design and performance standards using green infrastructure. As was mentioned before, they are constructing an infiltration basin. The infiltration area is only the 6,000 square foot area at the very bottom of the basin that's highlighted in that orange color. The rest of the infiltration basin in the lower portion is grass, and the upper portion extending back is remaining as woods. So in the case of the 100-year storm event, runoff filling the basin is going to reach back into the wooded area and use that as detention. Oops. Excuse me. So under the old rules, it was okay to use a large-scale infiltration basin like this to meet the water quality, the quantity, and the recharge standards. However, under the current rules, GIBMPs from Table 5.1 are required to be incorporated for quality and recharge standards. So the small-scale infiltration basin listed in Table 5.1 has a contributory drainage area limit of 2.5 acres. And the infiltration basin proposed here has a contributory drainage area of 5.5 acres. Therefore, it's not a small-scale infiltration basin from 5.1. Instead, it will be an infiltration basin from Table 5.2, which will need a variance or waiver in order to be used to meet the water quality and groundwater recharge standards. So in this case, if this site was being designed under the current rule, an option might be to incorporate into the design multiple small-scale infiltration basins or small-scale fiber retention basins, each with contributory drainage areas equal to or less than 2.5 acres. And the areas here highlighted in green just might have been an option for some of the locations of some of those small-scale BMPs. Okay, next we'll look at the stormwater management measures they're using. It's a good idea to see if the basins are acceptable before continuing on to review the calculations, just to find out that the basin isn't acceptable anyway. And in that case, they would have to redo all the calcs and you'd have to re-review. So it's a good idea to check the basin first. And for this basin, there's only 6,000 square feet of infiltration area. And with a 6,000 square foot infiltration area, according to Chapter 12, they would have to do 2 soil profile pits in the infiltration area of the basin. So what was actually provided was only 1 soil profile pit in the infiltration area of the basin. But they did complete an additional four soil profile pits that were very near the basin, just surrounding it. And that probably comes down to performing the soil testing before they found the exact location where the basin was going to be. But even so, that doesn't really meet the standard. So it depends on the situation, of course. You have to use some judgment in these cases, but we'll have to look at the soil profile pits to see if it's worth asking them to do more soil testing. Are all 5 soil profiles really similar? So in that case, you can probably accept them. Or is there wide variation, in which case you would really have to push them to do more soil testing in the infiltration area of the basin. The other thing they have to do is determine permeability in the soil. In this case, they used undisturbed tube permeameter tests, which are acceptable tests to use. Keeping in mind that if using tube permeameter tests, they need to be undisturbed samples. Disturbed samples really don't meet the standard. So here's a detail of the basin. It shows the ground elevation of the bottom of the basin. It shows the water quality design storm, the 210 and 100-year storm elevations. And it also shows where they estimated the seasonal high water table to be. So keeping in mind, an infiltration basin needs to have 2 foot of separation from the seasonal high water table. But that 2 feet of separation needs to be measured from the bottom of the sand layer that's required. So the sand layer has to be 6 inches thick. So really, from the ground elevation that you would be walking on if you were in the basin, it's really 2.5 feet of separation from the seasonal high. And that's exactly what they're showing on this detail. But we really need to check the soil logs to determine if the seasonal high water table is actually at an elevation of 9.5 feet, like they mark here. Okay, like was mentioned, there are 5 test pits, 1 in the basin, 4 just outside the basin. So this is test pit number 1, and it's inside the basin. This test pit basically shows sand throughout, but down to a layer between 39 inches and 60 inches, we start to see some modeling, which is a good indication of the seasonal high water table. You can see up at the top of this that the tests were done in May. So this actually would be a problem if they were trying to use direct observation of the water table because it's just outside the wet time of year, which would be between January and April. Now we might be able to have a discussion because it's just outside that period and depending on how wet of a year it was, but fortunately we don't need to go down that road because we see modeling here. They noted down at the bottom that modeling was down to elevation of 9.5 feet. So that's where they've established the seasonal high water table at elevation 9.5 feet. Also on the right-hand side, you can see that they collected an undisturbed sample at 24 inches deep. So keeping in mind that the sample that they collect and test needs to be in the most hydraulically restrictive layer that's above the seasonal high water table. And it seems the sample is at an acceptable depth here. Right, there's a sand layer, then there's the loamy sand layer, and they took the sample from that more restrictive loamy sand layer. So here's test pit number 2. Looking at it, it's pretty similar to the first one. You have sand, then you have loamy sand, and then start to see modeling. They took their sample in the loamy sand to sandy loam layer, which again appears to be the most hydraulically restrictive layers, so that's good. And we can see here that the modeling happens in this one a little deeper than in the previous test pit. It's at an elevation of 9 feet rather than 9.5. Here's test pit 3, also similar. Seasonal high water table 9.5 again. Test pit 4, same thing. Seasonal high water table comes out to 9.4 here. And the last one, test pit 5, again, looks very similar to the others. So as to the question of whether or not we could accept this with only one soil profile pit in the infiltration area of the basin, in this case, since 4 others were very near the basin and the results look very similar to the profile pit that was actually taken from inside the basin, I'd say it's no problem here to just accept these even though they're not inside the basin. We have plenty of evidence here to show that the water table is low enough to have that required 2-foot separation. And this is just a summary of all the seasonal high water table elevations that we saw in the various test pits. The highest of these is 9.5, which is exactly what they put on the detailed drawing. So here again, the detailed drawing you could see, they put an elevation down as 9.5. And that is exactly what's required to have that 2-foot separation, since the bottom of the sand layer is at an elevation of 11.5. So this is good, and it seems like the basin has the right separation. So the other question we need to answer with the soil testing is, does it have the right permeability? So this is an example of the results from a 2-permeameter test. The results are typically laid out like this. Important to note on here is you can see this is from test pit number 3. And we can also see that it was an undisturbed sample that was used. And the results are shown at the bottom, which shows that the tested permeability here is 6.54 inches per hour. And here's the infiltration rate summary. We're not going to go through every one like we did with the test pits, but here are the results for all 5 test pits. We see that in 4 of the 5 test pits, there are no problems with the infiltration rates. Those 4 are all above the minimum allowed tested permeability rate of 1 inch per hour. But actually, in test pit number 2, for some reason, we get a much lower permeability rate. And this rate is actually too low for an infiltration basin. So if we go back and take a look at test pit number 2, it looks like the sample was taken from the layer outlined in red here, which is brownish yellow loamy sand to sandy loam. And the description of that horizon wouldn't have necessarily indicated that results from an infiltration test would be so much lower, since the layers that were tested from the other test pits were similar. They were all loamy sand to sandy loam, but that's what the results were. So at this point, there would be 2 choices that the design engineer had. Either send someone back out there to do more testing and prove that this was just an anomaly, or the thing that they did choose to do, which is to replace that layer completely from the infiltration area of the basin. So they replaced down to the bottom of that layer throughout the entire infiltration area of the basin with K4 sand. So at this point, we know that infiltration rates will be good, and we don't have any issue. So next thing to look at is the drain time. Basin has a 6-inch orifice at an elevation of 13.2 feet. Bottom of the basin, or rather the top of the sand layer, is at 12 feet. So ponding depth is going to be 1.2 feet. The infiltration rate, they conservatively just used 1 inch per hour. And the drain time would be 14.4 hours. So that's far less than the maximum of 72 hours. Worth noting, though, is that if they if they follow all the standards in the B&P manual on designing an infiltration basin, the max depth of the water quality design storm is 2 feet, and the minimum infiltration rate in the field is 1 inch per hour, which means a design rate of 0.5 inch per hour. And if you run the numbers, you can't actually have a drain time that exceeds 72 hours if you meet all those standards. So this calculation is pretty basic and often doesn't mean a whole lot if the B&P manual standards are followed. But what's important, however, is that we need to look at the groundwater mounding analysis to determine how quickly the basin will actually drain. And we'll take a look at that in a few slides. But first, from there, let's move on to water quality. So we already established that the basin's going to get that 80% TSS removal. and it's an infiltration basin. We determined it meets the B&P manual. So at the time of this review, it's going to get that 80% TSS removal rate. So all we really need to do is determine that all of the areas that they have to treat for water quality are actually routed to the basin. So we would refer back to the plans and see that all the areas they need to treat are directed there. Keeping in mind that we require treatment of regulated motor vehicle surface for water quality. We wouldn't necessarily require treatment of runoff from rooftops. They may be sending that to the basin anyway, typically for stormwater quantity control reasons, but we wouldn't force them to do that for quality reasons. So this is the site again, and what we can see here is that all the roads are curbed and collected and flow towards inlets that bring the runoff to the basin. And there are also trench drains at the bottom. So basically, there's no way that the runoff from the road surface or the driveways could leave the site without going to the basin. So it looks like they meet water quality. So summarizing the infiltration, we saw that the basin has the 2 foot of separation. We saw the infiltration rate's okay, mostly since they're doing the soil replacement below it. We saw that the max water depth is 1.2 feet, so that's less than the 2 foot maximum allowed. And water quality design storm at 12.5 feet, which means the depth is only 6 inches, which is also less than 2 feet. So why is the orifice at 13.2 feet if the water quality design storm elevation only goes up to 12.5? And the answer is probably they are infiltrating the difference in the 2-year storm for recharge reasons. So that's probably a higher volume than the water quality design storm. And in that case, you can infiltrate a little higher than the water quality design storm. Just what you need to meet the recharge standard. And of course, the drain time, as we just mentioned, is less than 72 hours, but we'll check that more thoroughly with the mounding analysis. Here's the water quality summary. If there are trench drains capturing runoff at the lowest points on both sides of the site, and everything else is piped to the basin, all the runoff will go to the basin and it's going to all get treated for 80% TSS removal. So they meet water quality. Only other thing to note, which was previously mentioned, is that this was reviewed under the old rule, and under the current rule, water quality would need to be met, again, using GI BMPs from table 5.1 of the rules. So this is the groundwater mounding analysis they submitted. They used the groundwater mounding spreadsheet. They used the hand-tush equation. Hope you're all familiar with this after Module 3's presentations. You're going to see that 2 feet of separation from an infiltration basin, especially one that is even moderately large, is generally not enough separation for the basin to be able to drain within 72 hours. Maybe in certain cases where the soil is extremely sandy, and you have 20 inch per hour tested infiltration rate, something like that, very high, it may be okay. But in a lot of situations with infiltration rates in the 2 to 3 inch per hour range, 2 feet of separation is just not enough for the basin to drain within 72 hours. So they have pretty good infiltration rates here, especially with soil replacement. But if we go through what they did, they have 2.2 feet per day as the recharge rate. They used 0.26 for specific yield, which is high, which is on the high side. Horizontal conductivity is 22, that's 10 times the vertical conductivity. So again, this was done a while ago, and both of those values at the time were acceptable. Today, our default value for specific yield is actually 0.15, but we would accept up to a max of 0.2 for specific yield with supporting soil testing. And we would accept 5 times the vertical hydraulic conductivity in the coastal plain and lower if outside the coastal plain. And there's guidance on that in the B&P manual. So next are the dimensions of the basin. Keep in mind when using the spreadsheet, you use half the X direction, half the Y direction, not the full basin length and width. Duration of infiltration, they put 1.2 days. Initial thickness of the saturated zone, they used 30 feet. So the initial thickness of the saturated zone is one of the most difficult parameters to figure out here. Currently, we allow 10 feet for the saturated zone thickness. This value really should be, or should represent the depth from the seasonal high water table down to the first restrictive layer below that. So if they want to use a higher value than 10 feet, they would need to go out there and prove that, doing a continuous boring down to the depth that they're trying to use. And you have to make sure that it actually is a continuous boring, as not to miss a small restrictive layer, and for them to prove that there are actually no restrictions down to the depth that they're trying to use. So the results showed a groundwater mound height of 7.67 feet. And well, they only have 2 feet of separation from the seasonal high water table, and a groundwater mound of 7.67 feet is going to extend into the basin. So that basically means that in this 1.2 day time period that they put here, this basin is not going to drain. So let's make some modifications and see if this basin will drain within the 72-hour period. So here's a closer look at the results. Shown in the light brown color here is the bottom area of the basin, along with the elevation of the seasonal high water table, and the bottom of the 6-inch thick sand layer. So the calculations show the groundwater mounding is going to impact the basin within that with that 1.2 days that they entered in as input in the input section. This basin is not going to drain. So there's 2 choices. One is to redesign the basin, but 2 is to try to figure out a better answer for drain time. So at the DEP, we made some modifications to what they put in there. Keep in mind, we're trying to find out if the basin drains within 72 hours, within 3 days. So the infiltration period was changed to 3 days. And when you do that, you also have to change the recharge rate to maintain the proportionality. Peter had previously shown us how to calculate the duration of infiltration period. The horizontal hydraulic conductivity is the same because the vertical gradient does not really affect the horizontal rate. So when we rerun it like this, the groundwater mound is 2.44 feet. So this is 72 hours after the infiltration period. So at this time, the groundwater mound height will be 2.44 feet. And because this is the infiltration basin, it's got the 2-foot separation from the bottom of the sand layer. Then we have that 6-inch sand layer on top of that. So there's really 2.5 feet. And there won't be any ponding on the surface of the basin at this time, since we got 2.44 feet here. It will be just in the sand layer. And the sand layer will be saturated, but that's okay. So it seems like this basin will probably drain within 72 hours, and they avoided having to redesign the basin. So after we confirm that the basin, the water quality and groundwater mounding analysis are okay, we're going to want to look at the water quantity control analysis. So this is their chart. You'll notice that there is some runoff coming from off-site onto the site. And the way they're handling that is they're taking the pre-developed on-site peak runoff rate, they're applying the reduction factors just to those, and then adding the off-site back into that to calculate what the total allowable is. And that calculation seems to make sense. So what do we need to check? They use the NRCS method. So first thing to check is, are those numbers in those tables what the results of the calculation show? Did they calculate pervious and impervious areas separately? Is the rain depth correct, distribution right? Is the TC right? Do the land covers or HSGs actually match the field? Some other things, did they use the right unit hydrograph? Does the basin model match the plan? This has been seen a few times where the model doesn't actually match the plans. And another big one is, did they include infiltration in the routing? So back when this site was reviewed, our BMP manual did not allow exfiltration at all to be included in the 210 and 100-year design storm routings. But under the new rule, exfiltration is allowed for some BMPs. However, in the case of large-scale infiltration basins like they used here, exfiltration is still not allowed. So you can tackle these questions in whatever order makes most sense to you. But the first thing we're going to look at is some of the calculations. So this is the 100-year hydrograph for the entire site. It shows that the peak is at 34.67 CFS. And like we saw in the table, the 100-year total was 34.7. So that's pretty much the same. That gives a good indication already that the table matches the calculations. You want to run through some more calculation results and compare them with the table here, but you don't necessarily have to check every single number, because if some of these are right, chances are that the rest are also correct, since they're just like rerunning the same model again and again. Next, did they calculate pervious and impervious surfaces separately? For me, the easiest way to see this would be to look at the subcatchment diagram. You can actually just see on there if they're separated or not. One thing to be aware of, certain programs, HydroCAD is one of them, allow you to check a box in the settings that will calculate pervious and impervious separately, even though they're both input into the same subcatchment. So that's technically okay because it will produce the right volume. But you have to be careful if you're doing that, because when you're using the same subcatchment, it allows you, as far as I know, to only input one T sub C. So the only case where you should let someone do this is where the T sub C for both the pervious and impervious is the same, which is kind of a rare situation, or where the T sub C doesn't matter as much, like everything is draining to a lake on site. But in this case, this is the diagram of the model they used. We can see that they have broken into 3 areas here. The impervious surfaces are directly connected to the basin. There's other impervious surface and pervious surface. So they definitely separated it out here, and we can see that very easily without having to look into the calculations. All right, so if we do look to the calculations, we see, did they use the correct rainfall depths and distributions? Well, they used the type 3 rainfall distribution, which was okay at the time, but now the NOAA C or D distributions are required to be used, as was mentioned back in the calculations presentation in Module 2. In this case, the site is in Atlantic County, so NOAA C would have had to been used. But when this was reviewed, they used 3.3 inches, 5.2 and 8.9 inches for the 210 and 100-year storms, respectively. So here's a chart for all the various counties, and those numbers pretty much match up with what's here in the chart. So this may be actually where they got those values. They could have also gone to NOAA's website, which has more accurate rainfall data for the exact site, and that's the preferred option, but either one is technically acceptable. Okay, so the next thing that we're going to look at is time of concentration. So T sub C is another thing where it might not be necessary to look at every single one, but you might choose a handful and see if they're right. And if you start seeing mistakes, then you might be a good idea to look into them a little more deeply. This is one for existing conditions. They used 100 feet for sheet flow, woods, light underbrush with Manning's N of 0.4, and all those things match up. Right, the max Manning's N you could use is 0.4 in New Jersey and 100 feet for sheet flow. They have 3% slope, and that seems reasonable for the area. You can also measure that from the plans to double check, but with all this, the TC comes out to 23.5 minutes, and that seems okay. Proposed assumed TC was 6 minutes for all the impervious surfaces. Again, this is another deviation from the current rule, but acceptable at the time. There's no longer a minimum or default value for TC when using the NRCS method. TC must be calculated for both the pre and post conditions. So the next thing to check is if the land coverage and the hydrologic soil groups match the field conditions. First thing to ask is, what are the hydrologic soil groups? You should definitely have a soil survey that they provided to you. If not, you can look it up online. One thing to keep in mind, though, if you're looking at a situation where there's no HSG, or maybe it says something like on-site investigations required because the materials fill, then you really need to make them do the investigation on site. You can't just accept an assumption like if it's urban land, it must be HSGD. That's not true at all. It depends on where the fill came from. That influences the kind of HSG that the fill ends up having. If they don't want to do the testing, though, there is another option, and it's that they can use a conservative estimate. So if you're in the coastal plain, you could use HSG-A for existing and HSG-D for proposed. And if you're outside the coastal plain, you could use HSG-B for existing and D for proposed. And this is noted in our BMP manual. And that's very conservative, but you can accept that. But usually on-site testing is done. So this is the soil survey map for the site. The pink area is HSG-B, the green area is A/D, and the gray area is unknown. Let's see what they used in the calculations. This is from their report. So for woods, they used a CN of 30 or a CN of 55, which is good. That means they used either HSG-A or B for open space. They used a CN of 39 or 61, and that's also good because that's HSG-A or B for open space. And they did the same thing down in the proposed conditions. So it seems like the CNs that they used are pretty much match up with what we saw from the soil survey. One thing to note is that there was that one area of unknown HSG. That ultimately doesn't come into play for this situation because it was at the bottom left corner of the site, which wasn't being developed at all since there happened to be freshwater wetlands existing there. So the next thing to check is if they use the right unit hydrograph. Well, it's in the coastal plain and they use the Delmarva. So already right there, that's acceptable. Using the Delmarva is more conservative. The only time I would accept someone not using the Delmarva in the coastal plain is if the site was completely paved already, or the watershed has slopes that were really steep. In those rare cases, they could make an argument that the Delmarva unit hydrograph is maybe not applicable to their site. Otherwise, in the vast majority of sites in the coastal plain, should be making them use the Delmarva unit hydrograph. One question we get a lot is, can the Delmarva be used in the proposed conditions? Right, because the reasons we use Delmarva is that the site is relatively undisturbed, it's flat, it's interacting with sandy soils, and that lowers the flow. So, right, those things are gone in the proposed conditions, but if ultimately discharging into a basin, it doesn't make much difference because the basin is sized for volume, and the volume for both the hydrographs, SCS or Delmarva, is going to come out to be the same. The one time it does matter is if they're sizing something based on peak flow rate, like an MTD. So should definitely not let someone use a Delmarva unit hydrograph when sizing an MTD. So the next thing to check is if the basin model actually matches what's on the plans. So this is the outlet control structure in the basin model. Device number 1 is the outlet from it, so that's not really relevant here. But device number 2 is the inlet at 13.2 feet, and it's the 6-inch orifice, which is good. They also have a weir at elevation of 14 feet and a grate and a broad-crested weir, so the weir must be the emergency spillway at an elevation of 14.8. So if we take a look at the detail of the outlet structure, they've got an E-type grate at 14 feet, which checks out with what's in the model. And they have a 6-inch orifice, and that's also good. But on here it says that the orifice is at an elevation of 13.36 feet, which is actually 0.16 feet higher than what's shown in the model. So that's the problem. It's not a huge problem because it's not a significant difference, but it's definitely a difference that's going to have to be accounted for before this is given a final approval. Most likely what happened is they probably raised this up for groundwater recharge reasons and just forgot to update that part of the model because groundwater recharge doesn't really play into that. So we're just going to have them fix the model to show that everything still works with this orifice being slightly higher. Okay, next thing that we're going to check is if the shape and volume of the basin match what they're actually going to construct. So this is from the Stormwater Management Report. It shows that the elevation versus the surface area for the different levels of the basin from an elevation of 12 feet to 16 feet. So we could check one or two of these and see if they're correct, and if they are, we can assume that the others are also correct. So check the first one is the bottom of the basin. It's roughly 180 feet by 200 feet here, or 36,000 square feet. Of course, the basin really isn't an exact perfect rectangle, so it might be a little off, but somewhere around 36,000 square feet. If we look back at this, we see that the basin bottom is 36,430 square feet, so very close. And that's good. That seems right. Let's jump ahead to the highest one at elevation 16. Again, this is like nowhere near a rectangle anymore, but roughly 480 feet by 200 feet. That comes out to 96,000 square feet. You can expect it to be a bit off, but somewhere in that vicinity. And here we have 97,505 square feet. So that's really close. Just from those quick checks, it seems like the basin was input correctly into the model. So that's good. The next thing we want to check is if they used infiltration in the model. Generally, when you see infiltration, it's going to show up as infiltration or exfiltration. Sometimes it could show up as a custom outlet or discarded flow. It's usually shown in the outlet structure information, and we can see here that there's nothing like that. So they're not using any infiltration in this case, and that's good. Again, under both the old rule and the current rule, large-scale infiltration basins should not use exfiltration in the routing calcs. So summarizing water quantity control, everything looks pretty good except for that discrepancy with the height of the outlet structure. So they're going to have to fix that and rerun the model and send it back. But it seems like unless it produces some sort of significant error, which most likely it won't since it's such a small change, that water quantity is going to be okay. So next thing we need to check is groundwater recharge. In this case, the engineer opted to infiltrate the difference in the 2-year storm. So keeping in mind, you can use the groundwater recharge spreadsheet, or you can infiltrate the difference in the 2-year storm. Either are acceptable. They calculate the existing 2-year runoff here volume to be around 41,000 cubic feet, and the proposed to be around 100,000 cubic feet. So the difference there is around 59,000 cubic feet. And the volume below their lowest outlet is just around that volume. So that's probably why they raised the outlet control structure for groundwater recharge reasons. Again, so this is all okay at the time of the review under the old rule, but under the current rule, as with water quality, the BMP would require a variance from the GI standard in order to be used to meet the groundwater recharge standard, since it's a large-scale infiltration basin from Table 5.2. But at the time of the review, this was okay. So if groundwater recharge is going to be good, then you have to check the maintenance plan. So make sure they have one, first of all. Make sure it has a responsible party. In this case, they listed the developer as a responsible party, which is kind of okay, but not ideal. The developer is not going to be around after the development is done. So make sure to note to follow up with them later to revise this and put down a homeowners association or whatever the ultimate responsible party will be, but it's likely not going to be the developer in the future. They have preventative maintenance tasks and schedules. That's good. They have the required cost estimates They have blank maintenance logs, and keep in mind that it needs to be recorded on the deed where the maintenance needs to occur. So as long as they do that, everything seems to be okay with this maintenance plan. So in summary, the BMP design is good with that soil replacement. The maintenance manual was okay. The water quantity control was okay, as long as they make that change to the outlet control structure detail. And as for water quality and groundwater recharge, under the old rule, when this was reviewed, it would have been met. It would have been okay. But under the current rule, they would need a variance from NJAC 7:8-5.3, which is the GI standard, in order to use a large-scale infiltration basin to meet the stormwater runoff quality and groundwater recharge standards. Also, the stormwater management measure location and description will need to be recorded on a deed notice. So that's going through a whole review, and there will be a few other examples of stormwater reviews today. That's basically what today is dedicated to. So thank you so much for your attention. Should you wish to contact me, here's my info. But up next will be Lisa, who will provide a review of the GI fact sheet. And that's followed by an example where GI is also the focus. Thanks.
Thanks, Anthony. Can everyone hear me? Alrighty. So, as he said, my name is Lisa Schaefer, and we'll get started. In earlier modules, the guys introduced green infrastructure and some of the regulatory requirements. So today, I'm going to start with a review of the GI fact sheet that will help you better understand those rule requirements, and it will also show you how design should meet them, and this will help you when you are doing your reviews. Then I'm going to provide an example that says it's incorporated GI into the design, and then I'll evaluate it to see whether or not it follows what's spelled out in the fact sheet. All right, so fact sheet. All right, this part of the presentation, of course, is about the fact sheet, and it's going to answer the questions shown on the screen. Well, to get right to the first question, we covered in Module 1 what we mean by green infrastructure, and you'll hear me abbreviate it throughout this as GI. Dr. McGee also spoke about GI MTDs in Module 2, and Module 3 also included slides with information on GI. So to reiterate, a GI BMP is a stormwater management measure that manages stormwater close to its source by 1, treating stormwater runoff through infiltration into the subsoil, 2, treating stormwater runoff through filtration by vegetation or soil, or 3, storing stormwater runoff for reuse. So the fact sheet was created to help the public to better understand that GI is very important for managing stormwater, in that these BMPs more effectively maintain or mimic the natural hydrology, and they also provide environmental benefits by infiltrating precipitation to replenish groundwater and stream base flow, evapotranspiring and evaporating precipitation to reduce stormwater discharge volume, and intercepting precipitation to reduce runoff and erosion. Now, there are also co-benefits to using GI, and they include a reduction in the urban heat island effect, decreased energy use, removal of pollutants from the air through greater utilization of vegetation, plus beautification of public spaces and increased property values. So where do we find the GI fact sheet? On April 20th of this year, the njstormwater.org homepage was updated to its new format. The BMP manual is found by clicking on the lighthouse image or even the link text below it for the BMP manual. The fact sheet about meeting the green infrastructure requirements is now found on the lower right corner of the web page for the BMP manual, and it exists as a PDF file for you to download. Or you can use the link that's provided at near the top of your slides. And the fact sheet itself is an 8-page document. So it presents all of the information in the stormwater management rules, which you may hear me say refer to as the rules from this point forward. This is just a screen snip of a portion of the cover page. All right, so next we're going to look at what's in the fact sheet. But first, I actually want to see what the rules say about green infrastructure. In the rules, we can find this requirement where it's underlined in red on this screenshot of the rules. The yellow highlighted area right above the red underline is where it says the design and performance standards for groundwater recharge, water quality, and quantity control must be met using GI. Under item F in this subchapter is where you will find those tables 5.1, 5.2, and 5.3, and it is these tables which list the BMPs and identifies them as either 1, GI, 2, GI requiring a waiver or variance if used for other than quantity control, or 3, as non-GI BMPs. This information was covered in Module 1 in the overview presentation if you need to find that. Okay, also, Anthony touched on this in the How to Review a Project Part 1 on Tuesday. The tables have important notes and footnotes that should not be overlooked. So if you find that you need help understanding them, please contact us. The takeaway from this is that, first of all, the rules require a project meet the design and performance standards using GI. So that means usually Table 1 BMPs will be used as they satisfy all of the requirements. The Table 2 BMPs, as covered earlier, can be used to address stormwater runoff quantity control. But when used for the other design and performance standards, the Table 2 BMPs require a waiver or a variance, and Manesh will provide a brief refresher on variances in the next presentation. The Table 3 BMPs are not GI and therefore will also require a waiver or a variance to meet any of the design and performance standards. All right, so that brings us to the end of item 2 on this slide, which says that GI is to be used in accordance with subchapter 5.3. So let's take a look at what that is. All right, subsection 5.3 is where the rules identify which of the GI BMPs have fixed contributory drainage area limits. And a contributory drainage area is defined in the rules as the area that drains to a stormwater measure, excluding the area of the measure itself. So on the fact sheet below the first paragraph on page 1, these limits are restated. Now, I want you to take note that the GI BMPs found in Chapter 9 of the manual that are not listed here are those that have one or more design components that limit the size of the contributory drainage area. So, for example, grass swales, they're not listed here, but they have geometric constraints and a maximum depth of flow limitation that is 2 inches. So this design criteria will impact how much area can actually drain to a given grass swale. Okay, next is how to implement GI into a project or make sure it has been properly implemented. So the fact sheet includes a metric to help anyone evaluate if GI has been properly implemented. So with any design, the 3 questions that are shown here must all be answered with a yes for the project to meet the GI rule requirement. The reviewer will confirm that the answers are correct. So let's go through these questions individually. GI manages stormwater close to its source. So let's clarify what we mean by that. GI mimics the natural hydrologic cycle. And although stormwater traveling from this point on the right has a lot farther to go than a drop falling here to get to the basin over on the left side of the site, we have to remember that clearing, grading, and paving results in much shorter values that are calculated for the runoff travel times because pavement is much smoother than the natural terrain. Plus, we typically use uniform and flatter slopes, say, for our parking lots. So in conclusion, the basin that is not close enough to the runoff generated by the far right of the proposed parking lot, the basin's not close enough to the runoff that's generated over on the right. So also there's little opportunity for stormwater to interact with vegetation or soil in this particular layout. So this layout, what's going on? There we go, is not GI. All right. Now, this is an example of placing BMPs close to the source of runoff. And this is just the elevation view. I'll show you the plan view in just a moment. But the project description that goes with this kind of explains what's going on. A fully impervious 3-acre site in an urban redevelopment area is proposed to be redeveloped. The redevelopment will consist of a 1-acre building plus 40,000 square feet or 0.92 acres of parking areas and internal driveways, and also a 1-acre overflow parking area. A green roof and an underground cistern are proposed to manage the rooftop runoff from the 1-acre building. Stormwater islands designed to infiltrate into the subsoil are proposed to manage runoff from some of the parking areas and internal driveways. A permeable asphalt system designed to infiltrate into the subsoil is proposed to manage runoff from the overflow parking area. The proposed redevelopment is a major development since it disturbs more than 1 acre and is therefore subject to the design and performance standards in the rules. However, because it's in an urban redevelopment area and was previously completely disturbed and was also fully impervious, groundwater recharge is not needed. Additionally, the proposed condition reduces the impervious surface present in the proposed condition, so there's no recharge deficit. All right, and as I promised, this is the plan view of the site that we just saw in profile. Now, since the existing site is so highly impervious, many of the non-structural stormwater management strategies that are required by the local municipal stormwater management plan could not be easily implemented on site. However, due to the proposed GI practices, the project breaks up or disconnects the flow of runoff over impervious surfaces and provides for low maintenance landscaping that encourages retention and a planting of native vegetation and minimizes the use of the lawns, fertilizers, and pesticides. So in this example, all stormwater runoff generated by the redevelopment is managed close to its source, so we can answer unequivocally with a yes to the first question on the GI fact sheet. The next question to be asked is if the GI BMPs are dispersed throughout the site. So the previous example was certainly a good one, and that had a lot of BMPs spread all over the place. Well, here's another. The parking stalls are pervious pavement, and they're separated by impervious pavement aisles that are graded to direct runoff to the pervious areas. Roof runoff also drains to the subsurface storage beds below the pervious pavement parking stalls that are at either end without exceeding the drainage area limits. So yes, we can answer yes to this question for this site as well. Okay, now for a third site. The requirement to distribute GI throughout the site doesn't mean that multiple GI BMPs cannot be near each other. It's important that they be close to the source of runoff, like these dry wells are to the building for which they manage runoff. They are distributed because they're on 3 sides of the building. Now, if this is part of a larger site where there are additional GI BMPs, this layout is fine and a separate discharge for each of the 7 dry wells is not necessary. Now, as long as there's no more than 1 acre of runoff that's directed to an individual dry well, the drainage area limitations are met. And furthermore, to be GI, these BMPs must all function individually for the water quality and recharge storm. All right, but let's look at another one. All right, this small scale GI BMPs shown here are separated by berms, and they have contributory drainage areas below the maximum. However, all the BMPs are concentrated in one area of the site. Look how far the building is from this cluster. And notice that there's no stormwater BMPs on the right-hand side of the parking lot. Therefore, the BMPs are not near all of the sources of runoff. So in conclusion, the design does not meet the definition of GI and therefore does not meet the rules. Okay, the last question to be asked is whether the contributory drainage area of the proposed GI BMP is less than or equal to the limitation that we talked about that's on the cover of the fact sheet and in the rules at 7:8-5.3. So small scale bioretention basins are ideal for use in parking lot islands and where one is typically used in the past, perhaps a grass strip at the edge of a parking lot or along a roadway. So think small. The drainage area limit for this BMP, each of them is 2.5 acres. So that's generally more than enough for your purposes. All right. So next, we're going to look at an example with a drainage area map that clearly shows the limits draining to each of the proposed GI BMPs. And the goals of this part of the presentation are almost the same as for example 1, and I'm going to focus on GI. I will touch on the other compliance issues, but we're going to look at what's proposed and identify if and where the design falls short of the GI requirements, as well as the other design performance standards to a lesser extent. All right, and then what I'm going to do is present to you some ideas what could be done instead. All right, so of course, all reviews require figuring out which standards apply and then checking them for compliance. And the questions that we must ask and answer in our reviews is what is the disturbance on the site and does it trigger major development? Will the project be required to do water quantity, groundwater recharge, water quality, and groundwater mounding? And then, of course, we'll need to figure all of that out to see if they apply in this review and how they'll be addressed using GI as required by the rules. So, of course, it's important to know what the site looks like, what the pre-construction conditions are, and what is the existing land cover. Plus, we're going to need soil testing information. So let's take a look at what's going on in our example. The property in question is a farm that's been in existence for many decades. It comprises over 18 acres. The frontage road running east to west is a county route with sizable traffic volumes. The property is adjacent to some forested properties along the rear lot line, which is also a stream corridor for a freshwater non-trout tributary. The property drains towards the stream, which then flows to the south before crossing under the roadway on the east side of the property via a culvert. And here's a topographic view with some of the wetlands delineation and the 150-foot wetlands and riparian buffers that are shown in some of these dashed lines. Okay, so the proposed development includes the clearing and grading of the property, construction of 25 single-family homes, widening of the existing road found on the right side of the plan here, and another internal road. Both roadways will be constructed with 6-inch curbs and each will terminate in a cul-de-sac having a 50-foot radius. The stormwater management report indicated that 4.7 acres of impervious cover is proposed, but it didn't have a breakdown into the motor vehicle surface versus rooftop. Of course, that breakdown is important with the rule amendments. Now, I started checking the coverages, and the homes are about 0.35 acres each on average, so that should come to 8.75 acres. The proposed roadways are 28 feet in width, so by my estimate, roughly 70,000 square feet or 1.6 acres of new motor vehicle surface are proposed. Additionally, the existing portions of the roadway along the east side of the property will be newly collected where no collection system existed before. So it all counts towards a net increase in motor vehicle surface or and so forth. These totals clearly exceeded the threshold for major development. Now, for this project, then compliance will be demonstrated with the GI requirement, water quality, runoff quantity control, recharge, and if infiltration is proposed, groundwater mounting, plus the safety requirements, and of course, maintenance. So to address water quality and the GI requirement, 4 small-scale bioretention basins with under drains are proposed, and here's where they would be located. So first, let's look at the soil exploration map, which indicates quite a number of test pits were completed, although at the time that this plan was prepared, only one central basin was anticipated, where I've indicated here. So perhaps a preliminary concept predated the amendments to the stormwater management rules. Now, as you know, major development projects are required to use GI BMPs, and they're smaller in scale, and they treat stormwater runoff close to its source. So it's good that the designers realized the single basin approach wasn't compliant and went with multiple BMPs. But the reviewer would also want to check that for the revised design, the proper number of test pits and soil borings were performed. Now, in this case, the soil testing report was not revised to meet the testing location requirements for the updated multi-basin layout. So anyway, from the test pit findings, the seasonal high water table was determined to be at depths between 3 and 6 feet, mainly because modeling was observed. And the teal colored boxes that you now see show these depths below existing grade. Where the depth is preceded by an asterisk, cemented soils were observed. And additionally, from test pits 10, 11, and 12, the tested permeability rates were far below the minimum field rate of 1 inch per hour, meaning GI BMPs designed to infiltrate could not be used. Lastly, here are the approximate locations of the 4 proposed BMPs so that you can see which test pit most closely corresponds to each of the basins. All right, so now I want to look at the drainage area map for the proposed condition. And here it is. So hopefully you can see the contributory drainage area to each of the under-drained small-scale bioretention basins is less than the allowed maximum of 2.5 acres, which is specified in NJAC 7:8 under subchapter 5.3b. So that seems to meet one of the requirements for GI. However, the placement of the basins is too far from the source of the runoff. Plus, the GI BMPs should be distributed throughout the site and not grouped so close together as they are here. Why? Well, the motor vehicle surfaces are what are generating runoff with TSS that requires treatment, and the GI BMPs need to be near them. Now, if rooftop runoff, let's say, or other impervious cover that's not motor vehicle surface is commingled with the runoff from the roadways, then that commingled volume must be treated. But no information was provided regarding the roof drain off, so I'm a little concerned for this. All right, we're going to move on and look at each of the basins individually. So basin 1 is on the left side of the image. It's shaded in pink next to the cul-de-sac that's on the west side of the site. Runoff is collected in lawn area inlets and piped to the basin. Plus, the cul-de-sac is graded so that runoff flows to the east more than 50 feet along the curb to the inlet on the piping run, even though the basin is so close to that huge area of pavement. Basin 2, which is shown here in blue, is not close at all to the source of runoff, which, as previously stated, is the GI requirement. Its contributory drainage area is also, as you can see, is over here on blue, and it's way too far away from the basin. Now, basin 3 is the area towards the right that's also in pink. The basin is too far from the motor vehicle surfaces like the entrance road over here, as well as the internal roadway. The yellow area is for basin 4. And look how far runoff has to travel down the side road before it's collected in inlets and then piped to the basin. All right, so even though the drainage areas are below the contributory drainage limits, none of the BMPs reported as being GI BMPs are close to the source of runoff, nor are they distributed throughout the site. So this layout definitely does not meet the GI requirements. Lastly, I want to mention that there's a lighter green area in the center that has roof area generated runoff. It's not detained, and so I'm wondering how the site is going to comply with the quantity control design and performance standards. All right, so we know that the design does not meet the requirement to use GI, so that's strike one. All right, and later I'm going to make some suggestions on what could be done instead to make the project compliant for GI. But first, I just want to quickly go through the other instances where the project does not comply with the rules. So for starters, here's a basin cross-section detail. And the details for each of the BMPs show most of the requirements for online bioretention systems with under drains, meaning there's weirs and orifices to attenuate discharge from the larger design storms. So far, so good. However, I didn't see the bioretention media specification, so that would be something I would add to my review letter. I also didn't see a maintenance plan, so without these two items, the BMPs don't merit their TSS removal rating, meaning they don't meet the water quality standard. So that would also have to go into the review letter, and I'm going to call that strike two. Now, interestingly, the stormwater calculations that were prepared earlier in 2022 use the Type 3 storm distributions for the 2, 10, and 100-year design storms. But as per the 2021 publication of Chapter 5, and as Anthony said earlier, NOAA C and NOAA D distributions are now used. So that would also go in the review letter, and I would have to see new calculations. So far, it's not looking good for meeting runoff quantity control. And so I'm going to call this an error on the play. Now for groundwater recharge, this is where it gets very interesting. Just one second. Okay, for groundwater recharge, the report states the project demonstrates compliance with subsection 5.4 of the rules because all of the runoff is infiltrated. No, that's another error. They're only proposing under-drain BMPs. So maybe the designer thought that the movement of water or runoff through the planting media was good enough to meet the requirement, but under-drain systems are not infiltration BMPs, and they cannot be used to meet the groundwater recharge requirement. Furthermore, the narrative of the stormwater report even states that these under-drain basins are sufficient to address groundwater recharge because, well, they were claiming that the proposed 2-year hydrograph volume is less than the existing 2-year volume. And this excerpt is taken from the narrative. However, the narrative is incorrect as the calculations themselves show an increase in the volume of runoff by the proposed design. And I'm going to call this a strike 3 because they just don't demonstrate quantity control compliance. So to complete my baseball analogy, we're going to send the batter back to the dugout and have them revise everything along with the narrative. Now, one other thing I'm going to add at this point in my review letter is a reminder that if the design were actually infiltrating runoff into the underlying soils, then groundwater mounding analyses would have to be included. So that means that if pervious pavement, rain gardens, smaller planting areas or dry wells are incorporated into the design, then their impacts on the nearby structures would have to be required in addition to the assessment of the impacts of infiltrating stormwater into the BMP itself. I promise you, no more baseball, okay? But this image is a portion of the subdivision plan. And at this point, I'm going to give you some ideas of other things that they could do. So one possible component of a compliant redesign would be to consider regrading the portion near the entrance to the internal road so that road runoff could be collected into a bioretention swale that's shown in the yellow shaded location that I just added, and we would direct it around the eastern and northern edges of the property. So from the soil exploration map, we saw that the depths to the seasonal high water table was deep enough here. So this swale could be designed to infiltrate. And planting trees and shrubs in and adjacent to this bioretention swale would also help reduce noise from the main thoroughfare. Or you could go with a grass swale, but you'd have to check that the calculated velocity and depth of runoff comply with the design criteria. And maybe then you would add street trees closer to the main road. Anyway, this concept would have to be combined with something for other parts of the site. All right, for my second idea, I would make the internal roadway pervious pavement. The BMP manual indicates that the maximum ratio of additional inflow contributory drainage area to the surface area of the pervious paving system is 3:1, and in this case, we should be okay. Now, the lawn areas would have to be regraded to drain away from the pervious pavement, maybe towards that perimeter bioswale that was on the previous slide. And the driveways on the north side of this internal roadway could also sheet flow onto the pervious paving, and runoff from the lawns would have to be diverted away from the roadway to minimize intrusion of sediment onto the porous pavement surface. But this system could also be designed to attenuate discharge to meet the quantity control requirement. And similarly, the other cul-de-sac down here could be changed to pervious pavement, but this one would have to have an underdrain since the depths to the seasonal high water table were more shallow. Okay, my third idea involves moving the yellow shaded corner house to the location of the access road and placing a small scale bioretention basin with underdrain where the house was. Runoff from the road on the right could be directed into this basin via curb cuts, or you could use a gravel or vegetative filter strip, or even openings with a trench under the sidewalks. Now, of course, the backyards down here would have to be regraded to direct runoff away from this structure. Okay, another approach would be small-scale bioretention basins or rain gardens that I've shown here in green in the lawn areas between the homes, such that the driveways are graded to direct runoff to those to the swale we saw previously, and along the southern side of the internal roadway. And western side of the side road, we could have curb cuts that would direct runoff to a bioretention swale with underdrain that is shown here in light blue. Planting trees and shrubs in this swale-type bioretention system would lower the heat island effect from the pavement and would also create more of a park-like aesthetic. The plant lists on pages 45 and 46 of Chapter 9.7 include a great variety of bloom colors and the time when the plants typically bloom, which will provide additional pops of color to the landscape. And there are actually a few studies out there that show adding GI streetscaping not only helps with cool homes, but it can also contribute to safer travel speeds, lower the crime rates, and enhance a sense of community. Now, instead of paving the center of the cul-de-sac, you could also create a pocket rain garden. I know it's really tiny, but it's this little purple thing down here. All right, and that would receive runoff from the remainder of the circle. But you're going to have to check with your local ordinances to see if there's any prohibitions from doing this. Otherwise, this tree pit type bioretention system could also be another option that you would consider. Now, other ideas including give the owner the option to use raised planter boxes in part to receive roof runoff, and maybe even dry wells for clean roof runoff from the homes along the northern external driveway that I've shown here with the red dots. So this connection also helps in reducing the peak flow rates of runoff. All right, now I didn't really go into the groundwater recharge for this site because everything was under drained, but in this instance, the recharge spreadsheet would probably be the way to go to determine the deficit created by the proposed design. All right, now, if you remember, some of the areas had depths to the seasonal high water table of 5 to 6 feet below existing grade. And by using shallow vegetated planting areas along the road to the east where fill is proposed, plus the dry wells for the northern homes, they're probably going to be enough to address that deficit. So hopefully these ideas will help you steer a non-compliant design towards meeting the GI requirements to satisfy the design and performance standards in the rules. All right, so now just to wrap things up, this presentation covered what we meant by green infrastructure, which we abbreviate as GI, and it's a stormwater management measure that manages stormwater close to its source by treating stormwater runoff through infiltration into subsoil, or treating stormwater runoff through filtration by vegetation or soil, or storing stormwater runoff for reuse. The fact sheet is created to help the public to better understand GI and how to implement it, along with an example of clustering BMPs that is not GI. To address water quality, groundwater recharge, and runoff quantity control, the rules require GI be used, and by that I mean used correctly. So answering 3 questions when you review a design will check if the GI is properly implemented on a site, meaning the GI BMPs are located close to the source of runoff. They're also dispersed throughout the site, and that the drainage area limitations are met. So hopefully you found the example inspiring or at least educational, and I think you'll start thinking about how GI can fit better into your particular location. All right, so that does it for me. And at this point, I'm going to ask if there are any questions.
Yeah, there are questions in the chat, but I will try to answer that. So we can take a 5-minute break and come back at 2:26. Thank you.
Hey, Lisa, I have a question for you.
Okay.
Where I work, we're very densely developed urban community, and the majority of our redevelopment sites are about an acre, so they just meet the major development requirements. So I mean, if you're looking at a 200 by 200 foot lot, what's your definition of close and distributed? Because there's not a lot of space on the site to begin with.
Okay, so what are you building on the sites when you say redevelopment?
Usually it's a commercial property, so it's or a multifamily residential, so it's like a 20-unit apartment building on top of a parking lot.
Okay, so
I mean, a lot of guys are trying green roofs now.
Yeah.
I mean, that's centrally located, but it's not distributed. It's at one location. And then they're doing a detention basin underneath the parking lot. I mean, I'm just trying to get a feel for what's GI in an urban environment, because most of these examples are for large tracts of redevelopment.
Okay, so we saw in my big Gigunda redevelopment example early on things like vegetated parking islands. I don't know if those fit where you would normally might have a gap for cars, people to walk.
I mean, most of these sites, they're buildings built on stilts.
Okay.
With parking underneath them, and they take up probably 80 or 85% of the property.
Okay, so I
mean, that's allowed by the zoning, so I don't know.
Yeah. Okay, so I guess things would, again, I know it's hard, but things would be probably dry wells, perhaps, maybe, I don't know if this is possible, using directing roof runoff to cisterns for maybe gray water in some instances, or landscape watering, that might help. If it was commercial, perhaps reusing some of that water for vehicle washing. I don't know. Chengi, do you want to weigh in? I can't see the chat, so
do you really need multiple approaches, or can you use one BMP or two? I mean, if you're adding cisterns, dry well, I mean, it just really becomes a very complicated system.
You may in an urban area, very urbanized area, that you may use like small scale retention BMP like rain garden on the surface and for water quality, and then direct the runoff going down to the underground infiltration basin, and have the storage underground, like under parking lot. We have seen the design like that. So so you can have that.
I mean, most of the designs I've seen are subsurface infiltration basins with some green roof component to lower the CN, but that's really the extent of it. I haven't seen too many distributed green infrastructure elements on these small properties.
The only other thing I could think of is for the water quality would be the GI MTDs, where they use vegetation or they are able to infiltrate.
Yeah. I mean, really, the issue is quantity, because they're covering the entire site with a building. So you're really you're capturing everything either on in a clean way. There's really no motor vehicle surface that gets water on it. I mean,
yeah. So that in that case, you can have under as we said that you may have the underground infiltration basin that with detention component to provide water quantity control.
Okay.
So we have been seeing a lot of like a stormwater chamber. They serve as the water quantity detention component. They've been installed in the underground infiltration basin to meet the requirement.
Okay.
Yeah.
All right. Well, thank you. I just wanted to, throw that out there.
Thanks. So I will continue to answer the question through the chat, and let's continue that the presentation. There will be example 3 by Minesh.
Yep, thanks, Chengi. Hopefully you guys came back from your break by now, and we're just going to get right into example 3. So the goals of this presentation are the same as those of the prior example. We're going to focus on whether the project meets the requirements for green infrastructure, and then we'll look at what was proposed and identify where the design is going to fall short. And then I'll discuss some ideas on what could have been done for this project. So let's take a look at what's going on in our example. We'll start with what the site looks like, what the pre-construction conditions are, and what is the existing land cover. The property in question, it's a site covering roughly 11.7 acres that is primarily undeveloped and wooded. Contains the abandoned ruins of a single-family residence and related outbuildings on the northwest portion of the site. And the site runs alongside a state highway. To the west of the property is a conservation easement containing a ponded area that's draining to a tributary of a local river. And the site itself receives stormwater runoff draining from the east side of the divided highway. And there are some mapped wetland areas on the site as well. So let's take a look at the drainage area map for the existing conditions. So here's a topographic view. As you can see, the arrows here depict how the site would flow. Some flow from the road to the northwest and some flow from the highway to the east. Everything is going to be flowing towards the southwest portion of the site, with the high point of the site being in the northern corner. The proposed development includes the clearing and grading of the property. There will be construction of 152 age-restricted affordable housing units in a single multi-story building, a single-access driveway, surface-level parking, and multiple stormwater basins that will discharge to the southwest corner of the property to support the existing drainage patterns. The project will be constructed in 2 phases. The first will include 84 units, and the second will be 68 units, which are located on the left side of the building as shown. From the stormwater management report, the narrative states there are 3 small-scale infiltration basins along the southern border that are designed to provide extended detention of the larger design storms, plus a northeast detention basin from the off-site runoff entering the site to the north and east. So immediately, there's a big issue with this design. All 3 of the basins proposed to meet the GI requirement. They're all grouped together at the southern side of the project. Again, clustering these BMPs together is not compliant with the GI requirements. Remember, the BMPs have to be distributed throughout the site and manage stormwater close to its source. The proposed design is going to rely upon infiltration of runoff to meet the groundwater recharge requirement and water quality. So let's look at the web soil survey results and followed by the soil testing data before we evaluate the overall design further. So as you see here from the soil survey, the site is mapped as HSGA, which is promising for infiltration. So let's look at the soil testing findings now. So 2 sets of soil investigations were conducted. A total of 20 test pits were performed. The first group shown in green are from April 2021, and the second group shown in blue, they're from January 2022. I've superimposed the 3 proposed small-scale infiltration basins onto the soil testing map just to show which test pits correspond to the respective basins. Your review would also include a check of whether a sufficient number of test pits and soil borings were performed, along with the depth of the investigation, which I'm not going to cover here because we're focusing strictly on GI right now. But I've also added the depth at which the logs show the soil permeability that was determined, taking note that groundwater was not encountered at any of these locations. The brown shaded rectangles denote results for other test pits. And test pits 3 and 5, groundwater was encountered at 5.5 feet below existing grade. For test pit 6, groundwater was found at 6 feet below grade. And lastly, a perched water table was found for test pit 8 at 10 feet below grade. As with the blue shaded test pits, groundwater was not encountered at the ones I did not call out. The report shows quite a variation in the test results for permeability, so let's look at a table of the testing results. So as you see, here's the table, and I've circled the locations where the field tested permeabilities were less than 1 inch per hour. Unless soil replacement is proposed, these locations are not really suitable for infiltration BMPs. Given the low permeabilities at the encircled test pits, we'll have a problem with the ability of the orange and yellow shaded basins to drain properly, and we'll add this to our review letter. Next, let's look at information found in the stormwater report, which states that the 3 basins are designed as small-scale infiltration basins, but we have to check if they actually are. So this is the node diagram from a stormwater management report for this project. These are usually upfront in the materials that are submitted, and I usually use them to look at how the site is modeled and make notations as I start my review. So as you can see, basins 27P, 24P, and 38P, they're numbered 1, 2, and 3, respectively, and they've been superimposed, the inflow areas taken from the basin summary reports, with the totals appearing in the brown shaded boxes. The node report shows basin 1 draining to basin 2, and that will then drain to basin 3, such that the contributory drainage areas appear to exceed the 2.5 acre limitation that's established in the rules and in the GI fact sheet. The connections between BMPs is something that has to be checked to determine if this is true. Remember from the fact sheet presentation that the GI BMPs have to function individually for the water quality and groundwater recharge design storms, and each has to meet the contributory drainage area limitation. Perhaps the drainage area map can provide clarification, and after that, we'll look at the construction details to see how this design is going to function. So here's the drainage area map for the post-construction condition. This shows the contributory drainage to each small-scale bioretention basin is less than the allowed maximum of 2.5 acres, which appears to demonstrate compliance with 7:8-5.3b. But we have to dig a little further to evaluate how individually versus connected the basins performed when it comes to the water quality, the 2, the 10, and the 100-year design storms. Before we dive into the construction details, I just want to say that I'm not including further review information for quantity control and groundwater recharge. For the required groundwater mounting analysis for infiltration BMPs, the only analysis was for Basin 1, and the most restrictive hydraulic conductivity with the factor of safety was not used in the calculations. So this should also be in your review letter. But all right, so here's a close-up image taken from the plans, and I've added construction details that shed light on how these basins are actually functioning. Basin 1 is on the right, and A-9 is the outlet control structure for it. The top grate is the sole means by which runoff discharges from the basin. Since the grate is at elevation 63, the water quality design storm is going to infiltrate, but the 210 and 100-year storms over top the grate, they're going to flow to Basin 2, which has outlet structure B-11. If you look at the detail, the lowest orifice has an invert of 50, which is below the water surface elevation of the water quality design storm that's contributory to Basin 2. So Basin 2 wouldn't meet the design criteria for infiltration basins that's according to our BMP manual. Similarly, the lowest orifice at outlet control structure C10 is below the water surface elevation of the water quality design storm. In conclusion, basins 2 and 3 do not meet the design criteria for infiltration basins according to our BMP manual and would not merit the 80% TSS removal rating. These contributory drainage areas would most likely be larger than the ones that you would find in Table 5.1. They would then be more suited for those in Table 5-2, which would require a variance before they can be used for quality and recharge. Waivers are for the enlargement of an existing public roadway or railroad, or the construction or expansion of a public pedestrian access, which this project is not. So the next slide here, we're going to revisit variances a little bit. So there are strict standards to be met in order to grant a variance. More specifically, the municipality has to have a mitigation plan in place that identifies what measures are necessary, potential mitigation projects, and or criteria to evaluate mitigation projects that can be used to offset the deficit that's created by granting a variance. Additionally, the conditions that are shown here, apart from the rules, must be met. The applicant has to demonstrate it is technically impracticable to meet one or more design and performance standards on site. Those reasons can only be engineering reasons, environmental, or safety reasons. Furthermore, the variance cannot be for the entire site unless an analysis is provided for each drainage area within a site. The applicant also has to demonstrate maximum possible compliance is provided by the design. Don't forget, there is also a reporting requirement for variances. So what's not shown in this excerpt is item 3, which is about the mitigation plan, which has to be within the same HUC 14 and approved no later than the preliminary or final site plan of the project. Moreover, if the variance is for green infrastructure, then the mitigation plan must use GI BMPs to manage an equivalent or greater area of motor vehicle surfaces. There are 7 other parts to the mitigation plan from this section of the rules that I've not covered here. But in short, a municipality cannot grant a variance now like it may have done in the past. So since information was also not provided on mitigation projects, this project is not compliant with our rules. So let's conclude the review of this example by answering the 3 GI questions for the proposed design, even though only one small-scale infiltration basin was actually proposed. They must all be answered with a yes for the project to meet the GI rule requirement. So 1, the BMPs were not located next to the parking areas, so the first answer is no. The BMPs were all located near each other, so they're all along the southern property line as you saw. So the answer to number 2 is also going to be no. And number 3, are the drainage area limitations met? It didn't look like basins 2 and 3 infiltrated the water quality design storm and were instead discharging downstream during the water quality design storm. So the answer here likely is going to be no. So to wrap things up, this project does not comply with the requirements to use green infrastructure to meet the design and performance standards for water quality, groundwater recharge, and stormwater runoff quantity control. But we can always talk about alternative designs that would be distributed throughout the site to make this project compliant with the green infrastructure requirements. So there are several approaches that could be implemented using the proposed layout to make it meet the GI requirements. So here are some possible ideas to consider. The stalls in the parking areas could be constructed as 1 or more pervious pavement systems. Or stormwater islands could be added to the parking areas. The west side parking area could have curb cuts to a grass or bioretention swale. Clean roof runoff could be directed to dry wells. The southern end of the eastern parking area could add a vegetative filter strip or a bioretention swale that directs runoff to a small-scale infiltration or a bioretention basin. The front detention basin, it could become a bioretention system for the additional aesthetics. Or another bioretention basin could be added to the west of the main driveway. Additionally, the plans call for a future garden center, so perhaps some of the roof runoff could be collected for use there. So those are just some things you could consider as an alternative. So that about does it here for example 3. Thank you for your attention. If you do have further questions on this example, you could always contact me at my email. Should you have anything else you want to say about this example, anything quick, you could also say it in the chat as well. Next up will be our common design examples, common design issues, excuse me, led by Cheng-Yi Wu.
Thank you, Manesh. Cheng-Yi, before you get started, we do have one person who's had their hand raised for quite a while, so I just want to make sure that we addressed his concerns. Daniel, was there an outstanding question?
No, sorry, I raised my hand and I didn't unraise it. I'll take it.
It's okay. I didn't mean to put you in the spotlight, but didn't want to neglect you.
No problem at all. But I do have one comment, and now that we're talking, when we're coming up with all of these distributed ideas, it makes it more and more complicated for a municipal inspector to go out and do inspections on in a efficient manner. It was easier when it was one centrally located thing that they could look at. And now it's going to be all over the place, and you have to look at various different components. So it's just, this is going to make it much more complicated, since the municipality is responsible for inspecting these things, to have efficient and effective inspections.
For privately owned sites, okay, yes, the municipality is just making sure that the responsible party is doing the maintenance. So that doesn't mean unless the municipality is taking ownership.
But I guess how do you verify that? Is it just on their maintenance logs, or are you actually going out to look and make sure that they're maintaining? Or is it dealer's choice?
What I've seen from our audits is where the municipality is overseeing correctly for these privately owned one. They go out once or twice a year to look at the logs and everything else that is required in terms of the cost estimates to see if there's been a problem that has begun to develop. Things like that. They're not necessarily going out, but you might have those that you say, you know what, we've had a problem with the site and the forecast calls for this much rain. Let's make sure we check this one to see if the problem has gotten better or worse, that type of thing. Where we do require in the maintenance logs that the designer put metrics that someone can check and see, okay, what's the normal water surface elevation in this thing? How long should it take to drain? So that and then the maintenance people are supposed to actually fill that information out in the log. So yeah, it is a lot more BMPs, and I hear you.
Okay. Thank you. That was just a commentary on it, but I think we're good. So
Okay.
Thank you.
Yeah, and if you have more questions, please email us. That's what we're here for too.
Okay.
Okay, let's start the our presentation of the common issue. During the review, in this presentation, we'll be going over 5 of the issues if time permits, and we see most often that result in a project not complying with one or more rule or ACO requirements. So these are from project that we review during the MS4 audit. The goal of this presentation is to provide an overview of common errors in designs that we have seen in our reviews. This include not using the lane cover with the lowest runoff potential, improper pre-treatment, not capturing runoff from entrance and exits, post-approval plan changes and misapplication of the groundwater recharge exemption in the urban redevelopment area. The first issue is that the improper lane cover designation. The project we are going to talk about was reviewed by the township under the Stormwater Management Rule effective on March 1st, 2021, which means that the old rules, although it was under the old rules, the issue that we want to address are still valid under the new rules. Therefore, we will put the project in the context of Stormwater Management Rule effective on March 2nd, 2021. As of the Stormwater Management Rule state that for the pre-development site, a runoff coefficient for existing condition may be used if the design engineer verified the hydrological condition has existed on the site for at least 5 years, and also if more than one lane cover has existed during the 5 years immediately prior to the time of applications. The lane cover with the lowest runoff potential should be used for the computation. So here aside, there's a site plan, there's a proposed redevelopment, and that is submitted to the township in 2012. The plan shows the pre-construction condition. You can see that there are buildings extending to the right upper right corners of the site and pavement on the top of the site. So when we look at the aerial photos of the site in a side-by-side comparison, we see that the land cover existing in 2012 has the lowest runoff potential that could have been used for the pre-construction condition. And you can see there's vegetation on the ground. However, the stormwater management report of this project used the land cover exceeding in the past 5 years, which was 2007, to calculate whether the increase of the new impervious surface reached a quarter acre or more, along with the flow rate and volume of the runoff from the site. So when the site the site plan submitted to the township shows the land cover, which is not in 2012, the time the application submitted to the township for review. It used the land cover that in 2007, so they'll make a big difference. So so back to here. If that project based on the land cover 2007, and they do the redevelopment, is most likely there's no increase of impervious surface or regulated motor vehicle surface, so water quality is not required. And also, it seems like the water quantity would be easy to be achieved because from the 2007 land cover is almost covered the entire site. But if based on the land cover that right before, immediately before the application being submitted to the township for review, that if they put buildings and pavement on those vegetated area, there would be an increase of the impervious surface or regulated motor vehicle surface. And also that will likely to trigger water quality requirement and also would require water quantity control. So we want to emphasize that for the impervious surface that's being removed from the site before the application submit to the township for review, that those removed impervious surface cannot be counted as existing impervious surface. Okay, next would be Lisa.
Thanks, Changyi. Okay, so pre-treatment is essential for many of the BMPs, particularly now with GI requirements. So it's very important to review what is proposed on an application and then compare it to what is required. Next slide, please. Okay. Pardon me. All right, in this project, it was approved sometime before 2021. A sand filter with underdrain was proposed to treat the runoff from an apartment building parking lot and provide quantity control on a site with HSG soils. Just one moment, please. First, I want to say that all sand filters are required to have some type of pre-treatment, and for sand filters with underdrains, this requirement is found on page 4 of chapter 11.4. Now, this is the detail that was provided. The engineer stated that a type B inlet with a snout is provided for pre-treatment. All right, let's look at what's required in the BMP manual. Next slide, please. Next slide, please. Yeah, there we go. So the BMP manual and the department's website are listed as the technical guidance sources under the rules. The word pre-treatment actually appears about 10 times in chapter 11.4 alone, which is for sand filters with underdrains. And what you see here is the text from page 5 of that chapter regarding forebays. So previously, this information was found on page 4 of the 2014 version of the sand filter chapter. The red box at the bottom highlights the other portion of the manual text, which says you can use other BMPs for pre-treatment, but you must follow all of the design criteria in the respective chapter, including the maintenance. So to bring this all home, a manhole or an inlet of some type that's placed in front of a BMP that actually requires a forebay or any of the other BMPs found in chapters 9 or 11 is not an adequate substitution. This is and was a deviation from the BMP manual. So even if there was a compliant waiver or variance, the sand filter with underdrain still does not merit the 80% TSS removal rate, and the design itself does not meet the water quality standard. So had this project been approved after the delayed operative date of the rules, the project would still be not be compliant, and the municipality would have been out of compliance with the MS4 permit requirements. Next slide, please. An additional issue is treating runoff at entrances and exits to a site, particularly larger sites like office complexes, shopping centers, public complexes, and warehouses. And often these areas have a large radius in the curb to fit trucks and emergency vehicles. And that's going to create additional motor vehicle surface. Now, granted, sometimes there's a change in grade to transition to the adjacent roads, but not capturing runoff is going to introduce TSS to the stormwater collection system in the roadway in most instances. So we're going to look at an extreme case. Next slide, please. In this case, the existing site is about 1.5 acres, and it is light woody vegetation along the property lines. It's also adjacent to commercial and residential uses and a church to the west. In the existing condition, stormwater current was flowing outwards to all of the property lines, meaning it's away from a high point in the interior of the site. And for this project, the design engineer evaluated 3 points of analysis from 3 drainage areas, and those are to the south and east, towards the streets for collection in the MS4, and to neighboring properties to the west. The web soil survey indicated that this entire site consisted of hydrologic soil group D, so not much infiltration was occurring on site. Next slide, please. All right, the proposed development consists of a 3-story apartment building in the center with a parking area and associated site improvements totaling about 1.4 acres altogether. The roof generated runoff would be treated by a bioretention system with an underdrain to provide stormwater runoff quantity control. And that basin is in the blue oval at the eastern corner of the property, and it then discharges easterly to the MS4 system along the bottom of the slide. The proposed motor vehicle surface drains in 2 directions. The yellow oval in the upper right of corner of the slide is the proposed sand filter with underdrain that will treat runoff from the middle and right portions of the parking lot. This system discharges northeasterly to a pipe, and then it goes southeasterly, as noted by the blue arrow on the right of the slide, to a manhole where runoff from both of the blue and the yellow basins converge. The flow combined then discharges to the MS4, and it continues along the bottom to the left on the slide. All right, the system then flows west under the roadway on the left side of the property. Back up the page, okay? Now, the red oval is a portion of the parking lot that discharges to the south, where it would enter that MS4 system in the roadway, but it's doing so without any treatment for water quality or quantity control. So this project does not comply with the design and performance standards. A trench drain, perhaps to collect the runoff, could have been one of the approaches to collect the runoff and then maybe redirect it for treatment and attenuation. Next up is Manesh, who will present issue number 4.
All right, thanks, Lisa. Let's look at another project. This one is going to focus a little bit more on deviating from approved plans. All right, so next slide. So on this site, it was said that it was completely paved. As you can see on the left side of this slide, there is a pool right in the middle of the site. However, it was not in use at the time. There were a few buildings that were in existence at the time that they were looking at developing the site, but this is what we got from an aerial photo on the right. Most of the pavement was ripped up, and it was dirt paths and parking lots except by the pool, but by the time we got there, the impervious driveways weren't even there anymore. So in all, the site was dramatically different than what we had received in the plans. Next slide. So looking further into the report, what we were provided was an existing coverage of 1.61 acres for impervious. The lawn was about 1/2 acre. And then the proposed condition, they state they increased slightly less than a quarter acre of regulated impervious coverage. Now, this is key because increasing more than a quarter acre or more means you would have to meet the water quality requirements. They are at 0.22 acres of increase, so they're very close to the trigger, but would not meet the conditions for this requirement. Next slide. Then what ended up being proposed was a 3-story building. And if you identify around the property lines, a fairly big island in the parking area towards the right is where they're identifying their pervious areas. So based on the information that they have given us through the designs and reports, we understand the total disturbance is at 2.13 acres. The increase in impervious areas is going to be slightly less than the quarter acre, as we discussed earlier. So the local SCO, it states that to be considered a major development, it either has to disturb an acre or more of land or create a quarter acre of impervious surface. The project does meet the 1 acre or more of land disturbance condition and will therefore still be considered a major development, even though it's not going to create more than a quarter acre of impervious surface. Next slide. But what ended up getting developed was different than what was approved. Eventually, they added a proposed 1-story, and they lost a pretty big area that they were considering pervious around the island, and they ended up putting an underground infiltration system. Under the current rules, using a subsurface infiltration basin for a drainage area that's less than 2.5 acres can be considered a small-scale GIBMP as long as the design criteria are met. One criteria is that the basin will need pretreatment of runoff to 80% TSS removal rate, but we didn't see one available to us with the plans for this project. Additionally, the roof runoff was commingled with the runoff from the parking lot, so the commingled runoff would have to be pretreated to 80%. If in a scenario they separate the roof runoff and direct it directly into the subsurface infiltration basin, may just need a leaf screen to pre-treat the roof runoff. These are just some design criteria you would need to consider, but back to the site plans, as you can see, the building itself extended further to the left, so it got even bigger. So as they built, they increased their building size, and as a consequence of doing this, they got rid of areas they considered pervious areas. So now proposed pervious areas have now changed to impervious areas. So the proposed site is going to look different than what was originally planned. And they were already considered to be close to triggering water quality, and with just being under the quarter acre of increase in impervious coverage. So as you see here in this aerial image, there was once a piece of vegetated area, but now they decided to pave it over, and there's more impervious coverage now than proposed originally, which would push them over the threshold for triggering water quality. With all this happening, they would need to meet water quality now. So just a key point, keep in mind here, don't stray away from approved plans unless it is reviewed again. Next slide. Now I'm going to throw it back to Cheng-Yi for issue number 5.
Okay, thanks, Minesh. The last example happens quite frequently. Here are some of the details of the project. The proposed development disturbed more than 1 acre, and it increased the area of a motor vehicle impervious surface by more than a quarter acre, and therefore require water quantity treatment, water quality treatment, and also groundwater recharge. However, the township exempted the project from groundwater recharge requirement because the township thought that all major development projects in the township is in the planning area 1. So is that correct? Let's take a look at the stormwater management rules, specifically the recharge exemption, to see if the review, the township was correct to allow the project to be exempt from the groundwater recharge requirement. The rules state that the groundwater recharge requirement does not apply to projects within the urban redevelopment area. The urban redevelopment area is defined as a previously developed portion of the area delineated on the state plan policy map as planning area 1. The key is that the site must be previously developed and part of an urban redevelopment area. If the site is not previously developed, or if the site has been developed in the past, but the structure has been removed and vegetation has been reestablished, it's not considered previously developed. So there's an aerial photo showing that the proposed development will merge 2 individual lots. One lot is wooded area and that has not been developed. And therefore the portion of the undeveloped lot does not qualify for the urban redevelopment area, even though the lot is in the planning area 1. So therefore the portion of the site cannot be exempt from groundwater recharge requirement. So there is the common issues we have seen. And if you have questions, here's my contact info. I think we would, yes.
We have Scott Hatfield has asked one question and it pertains, I believe, to your slide 21.
My slide 21, okay.
Yeah, and he says, if this was one lot, would it qualify for the recharge exemption?
If it's, as we said, that for that area that's not being developed. So if there is one lot and the lot was previously only developed to the line, I mean, as you see that right now it's 2 lots. If the lot was only developed to the portion of the lot and on the left-hand side and the right-hand side, although it's one lot, it was never being developed. It was remain as a wooded area in the from the past. I don't think that would be qualified as previous developed area. Are there other questions, Lisa?
No, we haven't done the quiz, Robert. But one thing, Scott, one thing we'll add is if a site was impervious and then woody vegetation grew back, that vegetation is able to reestablish the ability of the surface to, runoff on the surface to reach the root zones, because clearly some hefty vegetation has managed to reemerge. So if there's woody vegetation, it's no longer exempt, and only previously disturbed portions where you haven't seen the woody vegetation come back would meet the definition. Does that help? Okay, we have the quiz next, and Peter's going to take control and run things from here. But if you have more questions, please feel free to put them into the chat.
All right, good afternoon, everyone. I will share my screen here. And we're going to get right into quiz number 4. But before we start the quiz, we would like to remind you of a few important things. Upon conclusion of the course, we'll send out via email a course evaluation survey. The survey must be completed to receive either a certificate of course completion or a certificate issuing CPC credits. So, if you review for an MS4 permittee, attended all 4 modules, complete all 4 quizzes, and are required by permit to complete this training every 5 years, you'll have to complete the survey before we send out the certificate of course completion. Likewise, if you are a professionally licensed engineer and you wish to receive a certificate issuing CPC credits, completion of the survey is prerequisite to us issuing any credits. Also, just to note that the slides and recordings for this training will be made available on the training webpage at the link here, and they'll be updated for future sessions of this course, which we typically try to host twice a year. All right, getting back to the quiz now. You guys know this pretty well, but you can access the quiz in a few ways. There's the link in the middle of this slide to take you to the training webpage, which has the link for the quiz 4, along with the other quizzes in the handouts. And then there is also the direct SurveyMonkey link, which should be posted into the chat. And then finally, there is the QR code, which you can use with your smartphone to take the quiz on your phone. All right, and I will also note that the quiz is open, so everyone should be able to access it now. Now, when you start the quiz, you're going to notice that some of the quiz questions will be new and some will actually be repeats from previous quizzes. These are the questions that had the lowest correct answer percentage. So it's going to be sort of a recap of the most difficult questions. As usual, we will review the quiz after everyone is finished. Please make sure to click submit at the end of the quiz to get credit for completing it. And it's about 3:11 right now, so we're going to give, let me see here, 15 minutes for the quiz. So if everyone can come back at 3:26, and we will get started with the review at that time. Here's the link and the QR code again, and you may begin the quiz.
Okay, folks, we have about 91% completion rate. So Peter will get underway, as we said, and then we have his presentation and followed by Natalie, that are all part of the training. Thank you. Peter?
All right, thanks, Lisa, and we're going to get right into the review here for quiz number 4. All right, so let's start at question number 4, true or false. Green infrastructure, or GI, is defined in NJAC 7:8 as a stormwater management measure that manages stormwater close to its source by 1. Treating stormwater runoff through infiltration into subsoil, 2. Treating stormwater runoff through filtration by vegetation or soil, or 3. Storing stormwater runoff for reuse. And that is true. The definition quoted here matches up with what is found in the rules. Question 5. Which questions need to be answered yes when designing a major development to meet the GI requirements? The answer is D, all of the above. So as found in the GI fact sheet, the stormwater must be managed close to its source, the BMPs must be distributed throughout the site, and the drainage area limitations, as applicable, must be met when designing a major development to meet the GI standards. Number 6, which of the following GI BMPs has a contributory drainage area limit that is other than 2.5 acres? Correct answer is dry wells. Dry wells have a 1 acre contributory drainage area limit per 7:8 5.3b. This information was also in the slides from the GI fact sheet presentation. Question 7. Unless a variance is granted, which of the following BMPs cannot be used to meet the quantity control requirement? And the answer is extended detention basins from Chapter 11.2 of the BMP manual. So in accordance with NJAC 7:8 5.2, extended detention basins cannot be used unless a variance is granted. The presentation for example 3, specifically slide 12, included the information on what must be in place for a municipality to grant a variance from the GI requirements. Number 8, yes or no? Can GI BMPs be located near one another for the following scenario? There are 7 dry wells located adjacently on 3 sides of a large building. No more than 1 acre of roof runoff is directed to each individual dry well, and each dry well will function individually for the water quality and recharge storms. The answer is yes. The material is covered in slide 13 of the GI fact sheet presentation from earlier today related to this question, and you can find more information about this setup on the GI fact sheet itself. The important factor here is making sure the answers to the 3 questions for GI are yes. Number 9, which of the following is recognized as a co-benefit of using green infrastructure? And the answer is all of the above. As described on pages 1 and 2 of the green infrastructure fact sheet, all 3 of these are environmental, social, and economic co-benefits of using green infrastructure. Additional co-benefits include increased property values and the removal of pollutants from the air through greater utilization of vegetation. Number 10, yes or no? Is the interconnection between GI BMPs in the following scenario acceptable? A small-scale bioretention system infiltrates runoff for the water quality and groundwater recharge storm events, meeting the 2.5 acre contributory drainage area limitation. The 2, 10, and 100-year storm events are discharged from the small-scale bioretention system to a large-scale infiltration basin, which is used only for water quantity. And for this question, the answer is yes. From NJAC 7:8 5.2, the downstream large-scale infiltration basin can only be used to meet the quantity control requirement and is not subject to the contributory drainage area limitations found in NJAC 7:8 5.3b. Additionally, the upstream small-scale bioretention system fully infiltrates the water quality design storm and the recharge storm. Number 11, true or false? BMPs from Table 5-2 can be used to meet stormwater quality requirements without obtaining a waiver or variance from NJC 7:8 5.3. And that is false. BMPs from Table 5-2 can be used for stormwater runoff quantity only. For them to be used for stormwater runoff quality, a waiver or variance from NJC 7:8 5.3 must be obtained. Number 12, true or false? A project located in a tidal flood hazard area is always exempt from the water quantity standard. That is false. In tidal flood hazard areas, the water quantity standard does not apply only if the applicant can demonstrate that the increased volume of stormwater runoff will not increase flood damage below the point of discharge. In tidal flood hazard areas, stormwater runoff quantity analysis is required unless the design engineer demonstrates through hydrologic and hydraulic analysis that the increased volume, change in timing, or increased rate of the stormwater runoff, or any combination of the three, will not result in an additional flood damage below the point of discharge of the major development. And no analysis is required if the stormwater is discharged directly into any ocean, bay, inlet, or the reach of any watercourse between its confluence with an ocean, bay, or inlet and downstream of the first water control structure. Number 13, yes or no? Can the Delmarva Dimensionless Unit Hydrograph be used for the redevelopment of a 2-acre entirely impervious site located within the coastal plain? The answer is no. The Delmarva Dimensionless Unit Hydrograph must be used when modeling watersheds within the coastal plain region of New Jersey, with just a few exceptions. It cannot be used to size a manufactured treatment device, or MTD, as it may underestimate the peak flow rate entering the MTD. Also, for an entirely paved site, the significant surface storage associated with the coastal plain is no longer present, also resulting in underestimated peak flow rates if the Delmarva is used. Additionally, the Delmarva should only be used in areas that have an average watershed slope less than 5%. If any of these situations are proven to be present, the SCS Standard Dimensionless Unit Hydrograph must be used. Also, a side note on this subject, if the Delmarva is used in the pre-construction condition, it must also be used in the post-construction condition. Same idea goes for the SCS. Number 14, soil testing logs prepared in accordance with Chapter 12 are required for which of the following BMPs? The correct answer is all of the above. All of these have a minimum separation from the seasonal high water table, which you can find in their respective BMP manual chapter. Soil testing would therefore be required for all of them to ensure that they meet the required separation. Number 15, which of the following would be exempt from the groundwater recharge standard? And the correct answer is B, previously developed portions of a site in a designated center. Just being in Planning Area 1 is not an allowed exemption from the groundwater recharge standard, nor is redevelopment automatically exempt. Only previously developed portions of sites in the designated locations listed on the slide can be exempted. Number 16, which of the following conditions must be met when a stormwater BMP is allowed to infiltrate the entire runoff from the 2, 10, or 100-year storm? And the correct answer is all of the above. Infiltration of the entire 2, 10, or 100-year storm is allowed only when existing site conditions are such that no runoff leaves the site for the pre-construction condition scenario, thereby constraining the design to infiltrate 100% of the volume produced by the post-construction condition for the same design storm. The maximum storm that can be entirely infiltrated is the largest storm event with no runoff leaving the site in the pre-construction condition. For example, if there's no runoff for the pre-construction 10-year storm, but there is for the 100-year storm, then the post-construction condition, for the post-construction condition, the maximum design storm that can be fully infiltrated is the 10-year storm. And then the answers for B and C paraphrase what is found in the rules, that only small-scale GIBMPs can be used to infiltrate runoff of a storm larger than the water quality design storm unless required by another rule or agency. And soil testing of saturated hydraulic conductivity must be performed strictly following Chapter 12 of the BMP manual. All right, so that concludes the review for Quiz 4. And up next will be Natalie Young with an MS4 program overview and some closing comments. So please stand by while Natalie takes control.
Hi, everyone. Just give me a second to put up the slides. Okay, can everybody see the slides?
Yes, you're good to go.
Great, thank you. Good afternoon, everyone. My name is Natalie Young, and I work in the MS4 unit in the Bureau of NJIPD Stormwater Permitting and Water Quality Management. We will wrap up today with an MS4 program overview and closing comments. I will give a broad overview of the topics here. The department currently has permittees authorized under 3 types of MS4 permits: Tier A, Public Complex, and Highway Agency. There are currently 557 municipal permittees authorized under the Tier A permit. There are also a few municipalities that are not regulated under the Tier A permit because they do not have an MS4. These municipalities are not permitted under the Tier A because they are entirely sewered by combined sewers and have a CSO permit, or because their stormwater sewer system is not publicly owned. The Tier A permit was last renewed in January of this year. As part of the renewal process, the department addressed EPA's concerns to reevaluate the Tier A and Tier B designations to determine if any of the town's MS4 systems needed to be authorized under the Tier A permit. We found that all Tier B towns required reassignment due to population density increases in urban areas or due to discharges to impaired waters and/or waters with TMDLs. Other MS4 permits include the Public Complex permit and the Highway Agency permits. We currently regulate 69 public complex facilities, which includes public colleges, universities, hospitals, and prisons. The Public Complex renewal permit is currently due to expire at the end of this year, so it is being drafted and anticipated to be finalized by January 2024. There are 33 highway agencies regulated under the Highway Agency permit, including state and county DOT roads. This includes agencies like the Turnpike, Bridge Commissions, and the Parkway. MS4 permits have a number of key requirements, including these key requirements noted here. We will be going into more detail regarding these requirements later in this presentation. In the meantime, take a look at this list. Just to note, we have only listed some of the requirements on this slide. I'll discuss the enhancements to the Tier A renewal that became effective January 1st shortly. This is a list of notable changes in the Tier A permit renewal. I'll give you just a moment to read the list, and then I will go over some of the changes in more detail. Please note that the permit includes other changes. There are some new BMPs for maintenance yards. Excess salt and de-icing materials have been deposited during spreading operations on all municipal roads, and parking areas must be removed within 72 hours after the end of the storm event. We are asking for a dedicated stormwater page on each town's website. Employee training for municipal employees has been modified to once a year, and street sweeping schedule has also changed. Many of these enhancements have been made to address water quality problems, such as impairments and TMDLs that affect waters throughout the state. There is no change to this permit condition. The 5G3 Master General Permit was recently renewed with a few changes and is available on our website. There are two minor changes to this condition. First, we clarified that the permit language to say that the design engineers cannot approve their own designs. Next, for any amendments to the stormwater management rule, training sessions will be necessary for stormwater design reviewers. This is because attendance at this training is only required every 5 years, and we don't want you to wait that long to train people on amendments. Rule amendment training sessions will be announced by the department on the website and via email to all stormwater program coordinators and people who have attended previous SWIMBR courses. Attendance will be mandatory and must be completed within 1 year of the adoption of the amendments. We have added 2 new ordinances for municipalities to adopt. The first one is a private salt storage ordinance requiring owners of private properties and businesses such as malls, shopping centers, etc., to properly store salt and other solid de-icing materials. The next one is a tree removal replacement ordinance to reduce runoff and to promote infiltration. Some towns may already have a similar tree ordinance, so if your ordinance is at least as strict as our model that the department is providing, it may not be necessary to adopt our model. Please note that we put out the draft ordinances for comment and are currently evaluating the comments before finalizing the ordinances. There is no change related to labeling inlets. The change here is that all remaining storm drain inlets that have not yet been retrofitted must be retrofitted by December 1st, 2027. The entire structure can be replaced with an updated one, or you may attach a bolt-on plate to reduce the size of the vertical opening of the old inlet. In addition, all newly installed inlets must have a catch basin or other BMP to collect solids. We also included an exemption for the catch basins on bridges. This is a condition that was in the 2004 Tier A permit that was removed in the 2009 permit renewal. The reason is that at the time, it was viewed as a redundancy since municipalities are required to control erosion under the standards for soil erosion and sediment control in New Jersey. However, those standards only apply to construction sites, not necessarily to existing roadways. And we have received complaints about ongoing roadside erosion in various towns. The photos shown on the slide was taken by one of our enforcement officers who was investigating an erosion complaint. So we have reintroduced this condition in the renewal. Erosion checks can be done while performing other stormwater inspections, so you don't need to schedule an additional trip to do this. If problems are identified, we allow 3 months to address it unless another time frame is authorized by the department. We wanted to clarify and point out that inlet inspections and catch basin inspections are different activities and have different schedules. The condition of stormwater drain inlets can be observed with a simple drive-by type of inspection and a quick sweep or shovel if the grate is clogged. For this reason, we require that all stormwater drain inlets are inspected every year. Catch basins, on the other hand, require additional work. The inspector must get out of the truck and inspect the inside of the catch basin to determine cleaning needs. Inspect a minimum of 20% of the total every year on rotation so that all catch basins are inspected by the end of the permit cycle. This is a clarification to highlight that the permittee is required to properly inspect, clean, operate, and maintain all stormwater management measures. This is a catch-all condition since it refers to all remaining stormwater facilities not mentioned specifically in another permit condition, such as stormwater management basins and MTDs. This program should define what conditions warrant cleaning, proper operation and maintenance of any remaining stormwater infrastructure, and establish an inspection schedule that is tailored to your municipality's characteristics and resources. If there is not an approved maintenance plan, towns can prepare a retroactive maintenance plan for certain infrastructure or inspect at least 4 times annually and after each rainfall of 1 inch or more, keeping this in mind that inspection logs must also be maintained. Here you can see a list of the new or modified BMPs for maintenance yards and other ancillary operations. Note that the requirements that were previously included in Attachment E are now in the body of the permit, not in an attachment. All the BMPs listed here have been modified from the 2018 permit with the addition of a few new BMPs. For example, the Tier A permit will no longer authorize stormwater discharges from wood chipping or leaf composting activities, as these will be covered under the department's new wood waste recycling and leaf composting general permit. These are the MS4 permitting training requirements. The SPC training requirement is required for all SPs so that they know their responsibilities for implementing their stormwater program. This is required once per permit cycle. The employee training requirements includes implementing an employee training program to address permit components and stormwater pollution prevention plan requirements. The SWMDR training requirement is the stormwater management design review training, which you guys are all in right now. The municipal board and governing body member training requirement is training for board and council members. This training is a higher level training intended to familiarize those members with the permit and permit requirements. This is required once per term. Original Tier A permittees should have already mapped their stormwater outflow pipes and will now need to add the rest of their infrastructure. Mapping is an entirely new condition for the new Tier A towns. This means mapping everything that collects or conveys stormwater, including outfalls, groundwater discharge points, interconnections, storm drain inlets, manholes, stormwater conveyance systems, pump stations, and any other stormwater facilities you have. You are also required to map the property boundaries and maintenance yards and ancillary operations. Permittees must submit the MS4 infrastructure map electronically to the department by January 1st, 2026. Electronically does not mean a PDF sent via email. Rather, it means submitting georeferenced shapefiles, geodatabases, or AutoCAD files with all other non-applicable data stripped out. The department has developed a free mapping tool for towns to use, and we can provide ArcGIS online licenses for free. Additionally, the tool has been updated to accommodate for any additional stormwater facilities and features that are required to be mapped. Kristen covered this information back on the first day of training. If the DEP mapping tool is used, data submitted is automatic. Otherwise, the files will need to be uploaded via the online stormwater document submittal service. The MS4 infrastructure map shall also be posted on the permittee's dedicated stormwater webpage when it is complete. Stream scouring inspection has been modified so that all MS4 outfalls are to be inspected at least once every 5 years. Municipalities must inspect 20% of the total annually on a rotation so that all outfalls have been inspected by the end of the 5-year permit cycle. Note that we broadened the scope of outfalls and the renewal to not just mean outfall pipes, so that will mean open conveyances as well. All new or newly identified outfalls, as well as complaints or reports of scouring, must be inspected within 30 days, and any reports of scouring need to be remediated within 12 months of discovery. The requirement for illicit discharge detection and elimination inspection has been modified so that all MS4 outfalls are inspected for illicit discharge at least once every 5 years. Municipalities must inspect 20% of the total annually on a rotation so that all outfalls have been inspected by the end of the 5-year permit cycle. All new or newly identified outfalls, as well as complaints or reports or illicit discharges, must be inspected within 30 days, and any report of illicit discharges need to be remediated within 12 months of discovery as well. There are many water quality impairments and resulting TMDLs that affect waters across our state. Some of these impairments affect fish and aquatic biota, our drinking water, and even the rivers and coastal waters that many of us swim every summer. Harmful algal blooms and many lakes due to water quality impairments are also occurring more frequently in the summer months. Some of these waters have no other discharges into them other than local MS4s. Therefore, the department requires that each Tier A permittee develop a watershed improvement plan to determine what improvements can be made to reduce their contribution of pollutants that are causing impairments to the state's waters. This watershed improvement plan will be split into 3 phases with separate due dates, which you can see here on the slide. The watershed improvement plan shall be updated when necessary based on the biennial review of revisions to the impairments of the permittees' water bodies based on the department's integrated report and newly adopted TMDLs. The department is offering a notice of funding availability to assist New Jersey municipalities in upgrading their MS4 stormwater programs to comply with the requirements of the 2023 Tier A MS4 permit renewal. The department is making $75,000 in aid available to former Tier B permittees to meet the compliance standards of the newly issued Tier A renewal permit. Eligible applicants must complete and submit the application form to receive the initial $25,000 disbursement of grant funds. Applicants must then submit an acceptable SP3 to receive the final $50,000 disbursement of grant funds. The department is making $25,000 in aid available to original Tier A permittees for the development, update, and maintenance of an MS4 infrastructure map delineating the location of stormwater features owned or operated by the permittee. Eligible applicants must complete and submit the application form to receive the initial $15,000 disbursement of grant funds. Applicants then must submit an acceptable MS4 infrastructure map to receive the final $10,000 disbursement of grant funds. To apply, just submit the appropriate application to the department. The application can be found on our website at the address on this slide. The application deadline is December 31st, 2023. In March 2019, the Stormwater Utility Law, officially known as the Clean Stormwater and Flood Reduction Act, was signed into law. This act authorizes local and county governments and certain other entities the ability to create stormwater utilities. These allow for fees to be collected to be used for stormwater-related activities. Depending on the unique circumstances in each community, the process to establish a stormwater utility may take up to 5 years or more. There is a lot of information on our website that outlines the steps for establishing a stormwater utility and has many resources on how to do a feasibility study and creating a fee structure. Please reach out to your case manager with questions about stormwater utility. Here is a list of the general categories which the stormwater utility fees could be used to pay for. Please refer to the stormwater utility website for more specifics on each category. The department's wood recycler's general permit, also known as the R7, expired in 2014 and a renewal was needed. This general permit allows the department to include multiple facility types and ensure that proper permit coverage is established for stormwater discharges from wood waste recycling activities statewide. The Stormwater Pollution Prevention Plan, also known as the SB3, is required to be submitted to the department within 3 months and then implemented within 12 months. It must also include the drainage control plan and the drainage control map. Here are some additional permit requirements. Here is the groundwater monitoring discharge limits. Please take a look. Here is the surface water monitoring discharge limits. Storm event parameters should be recorded every time a stormwater sample is taken, whether monthly or quarterly. Samples should be taken within 30 minutes from when stormwater begins to discharge from each monitoring location. Listed here on the slide are the required minimum site-wide BMPs that must be implemented. Permittees can choose to implement additional BMPs to mitigate pollution runoff and control drainage on site. Here is a more detailed sampling procedure which we approved for the WRC permit. And here are the chapters we are still working to update in the BMP manual. Please take a look at these handy references with links for the topics we mentioned earlier. You can find our contact info on this slide. If you have any questions, feel free to ask in the chat or unmute yourself.
Thank you, Natalie. We are actually very pressed for time. So at this point, we know that people have complex questions and we have the contact information here if there are questions pertaining to any of the MS4 permits so that someone perhaps could reach out to you. If there are additional stormwater management or BMP questions, please feel free to reach out to myself or anybody else in the unit. We really appreciate these are really great questions and we want to close on time. So thank you again, Natalie. And at this point, it is 4 o'clock. Changyi, do you want to add anything else?
I have nothing to add. Thank you very much for everyone attending the stormwater review courses. Thank you very much. And that's the end of our module.